All right, I'll start my presentation with this statement. I think Kubernetes is a perfect platform for building orchestration platforms, and I'm going to tell you why. You all know you all work more or less in the Kubernetes ecosystem, so you know that the ecosystem is quite huge. You have a bunch of operators, you have a bunch of controllers, which are capable of orchestrating complex use cases. So let's say you want to run PostgreSQL databases, you can take the cloud-native PG operator and orchestrate PostgreSQL clusters over the scale, upscale, downscale, etc. If you want to control your rollouts, or you want to centrally manage several deployments across several clusters across the globe, you can use Orbis CD. If you want to manage Kafka, you can use Streamzy, or even you can orchestrate a platform from your Kubernetes itself, resources, cloud resources using Crossplane. This is all nice. You have so many options out there, but you can end up in a situation where I was, where I found a project, a use case, where there was no specific operator, controller, which I could use. So I was forced to build my own. And actually, building your own controller is quite straightforward. I mean, not that straightforward as it sounds, but 3 simple steps. Just have to define a few CRDs. You can build your own controllers, and then you deploy it, and you hope it works, and it does what it's supposed to do. Yeah, so my name is Tomáš. I'm a DevOps engineer. I work as a DevOps engineer for a small Irish company based in Dublin. I work remotely from Slovakia. I do have some research background. I was working a lot on CDNs, and I was working doing research on video streaming, especially on MPEG-Dash. It's an abbreviation for Dane assisted. Am I wrong? Okay, no, sorry, I don't know what the abbreviation is, but it was actually a networking layer which was able to modify QoS fields in an SDN to make sure that the quality of experience of the video streaming stays high for the end user. And I'm a former developer of the Magio-Go CDN platform. For those who don't know, Magio-Go is probably a service in Slovakia and Czech Republic which is generating the largest traffic because currently only in peak times when there is a football match going on or a hockey match, the aggregated traffic peak is reaching over 3 terabits per second, which is more than the aggregated traffic through 6, which is the Slovak Interconnect Exchange. That CDN works quite well. Unfortunately, I no longer work on the project anymore because I had some other applications. And just to note, that CDN was basically mostly provisioned with Ansible. It's running bare metal servers, around 60 servers. The largest servers are streaming at 80 gigabits per second currently. So they are quite beefy, but unfortunately, the control plane, I would say, is getting out of control. And a certain improvements are needed to be done on the platform, and I no longer had access to this platform. So I decided that I'm going to build my own CDN. And that's why I've chosen this product, this goal, as my project, basically. So for those who don't know what CDN is, CDN stands for Content Delivery Networks, and it's a distributed network of servers placed across the globe, which helps you to cache content in those individual regions. Here in this example, you can see that there are several servers placed across, and the CDN helps you basically redirect the clients into those individual servers to make sure that the content is downloaded from the closest cache to the end user. This helps to reduce latency. Also, it reduces the load on the origin server and overall improves the user experience, improves CEO on websites because your content, your website is basically loading faster. In a CDN, you need to somehow get those clients to those individual servers. And most of the vendors are using DNS to achieve that. Ideally, you want the DNS be behind an Anycast IP. Anycast basically is an IP address, a prefix which is announced with BGP, and it appears to be available globally, so like the very famous IP address 8.8.8.8. It is not a single server, but it's a cluster of many servers that are announced from multiple places across the globe, and it makes sure that your request always gets to the closest endpoint. So what this kind of DNS does when you are trying to resolve a domain name, for instance, cdn.example.com, it will look up your IP address or other specific fields and will redirect you to the closest cache server. There are also alternatives. You can also use HTTP with Eddycast, basically directing the client directly to the node, or you can use a classic 300C redirection message where the initial request lands on a router, and the router will send you a 302 redirection message. This way, it will redirect you to the closest cache. Both of them have some advantages, some disadvantages. The DNS one is basically faster, but it converts slower. And when you're using HTTP, you can get into the calculation which edge to choose more parameters, such as user agent or your exact IP address. All right, and yeah, so the question, why did I choose Kubernetes? Well, first of all, I have good experience with working with Kubernetes, and I decided I wanted to join the know-how from Kubernetes with my know-how from CDN. And at the same time, Kubernetes has a fantastic reactive control plane. The Kubernetes API is etcd backed. etcd is capable of streaming you the changes that are happening on the database. So that means whenever there is a change, you get notified instead of having to pull an update from the Kubernetes API itself. It has a fantastic tooling. Just to mention a few, I've used Argo CD because it has application sets with cluster generators, and you can register multiple clusters from across the globe into a central Argo CD, and this way you can distribute the configuration into each and every region where you need those resources to be. And of course, you can extend it with custom resource definitions. Yeah, in terms of caching, the caching is ingress-based. I would say, unfortunately, Nginx ingress, yes, we all know it was deprecated recently. I was somewhere in the middle of the building the MVP, but I will say a few notes regarding ingress. I will keep working on ingress, but there will be certain changes probably from what the upstream is currently. It has a great support for certificates with Cert Manager, and you have a great DNS tool. DNS server available for Kubernetes, which is CoreDNS, is also written in Golang, and it is very nicely extensible with custom plugins. All right, just to see the internals, how Kubernetes is working and how and why it's such a good platform to building orchestration platforms. So in the end, in Kubernetes, every single component is a controller, and it continuously compares the desired state with the current state. So what happens when you create a deployment or a job or a pod or a replica set resource in a Kubernetes API that gets stored in etcd, and all the components that need to react on this resource type will pick up this event. So for instance, when you create a deployment, the kube control manager will create a replica set for that, and the replica set will create pods. Those will be picked up by the kube scheduler. The kube scheduler will find the suitable node to run the pod on, and it will allocate the pods to certain nodes where the kubelet, which is running locally, is picking up the manifest and will try to get the pod into desired state and run the container. So yes, of course, and Kubernetes is extensible, as I mentioned, with custom resource definitions. Custom resource definitions are basically models which you can define, and you can build controllers which will act on create, update, and delete events, and you can build a reconcilable which will help you basically to get that resource into desired state. So to building the controllers, I've decided to use KubeBuilder. It's a great tool chain specifically built for Golang. built-in domain, specifically built for Kubernetes, and it has the controller itself can run in multiple roles, in multiple modes, depending when my controller is running. So it also defines a few CRDs. These are the CRDs I'm defining with this platform. The most interesting ones are basically locations, services, and zones. The rest are just helper ones. The locations define basically where my endpoints are, what the IP addresses are, what kind of caching capabilities the individual nodes have. The zones are used by the CoreDNS itself. Those CRDs can be picked up by the CoreDNS itself and can register that zone, so it can resolve domain names from the given zone. And the services are basically service specs, which define which service is supposed to be cached on the node and what is the upstream, and some additional cache keys, etc. All right. At the same time, so just to go back a little bit on the architecture, so I have a centralized control plane that is currently, I have a demo deployment that's currently running in Frankfurt, and I have a DNS node, another kube cluster basically, which is running in Frankfurt as well, and two cache clusters that are doing the caching. One of them is running in New York, another one is running in Frankfurt, and the controller is the one that is responsible for creating application sets when you create a certain resource. So let's say you create a service. Here in Argo CD, on this screenshot, the service looks the same as the standard service, but this is not the standard service. This is services.infrastructure.edgecdn-X.com custom resource. When you create a resource like this, my controller picks up this resource. It will create an application set, and it will make sure that the service is distributed to all the endpoints to where which clusters are joined into this Argo CD cluster, basically. And it's also responsible for orchestrating the certificate issuance. Certificate issuance, in this case, is a bit tricky, because if you know how HTTP-based certificate issuance works, it works in a way that you get a token from an ACME provider. I'm using Let's Encrypt here, of course. You get a token, and you need to expose this token publicly behind your domain name. Although in a CDN, your request can end up in any of the nodes across basically your whole cluster. So there is the controller makes sure when the certificate resource is created, the certificate resource will create a challenge and an order and a challenge in this order. And the challenge is basically copied over to all the endpoints to make sure that all the nodes have the specific, the required token for the ACME certificate issuance. So this way, the certificate is issued, and then the content is patched back to the application set and is distributed to all the endpoints, basically. Okay, so this very same controller on a cache node can run in a different node. Essentially, it's the same code base, but with a different flag. In such case, when it sees a service resource, it will create a Kubernetes service, which is a type of an external service, which is pointing to your upstream, which you have configured. And it will configure the ingress as well, which using custom annotations in the ingress controller will make sure that the content not just proxied to your upstream, but at the same time is also caching into a cache. So those caches are defined on the deployment itself. All right, and this CDN is also capable of using S3 type of origins. So if you select an S3 type origin with this service, then instead of an external service, it will deploy a S3 gateway, which is Nginx S3 gateway based, and you can serve your private content from an S3 gateway using the CDN. And last but not least, the controller can also is running on a DNS node as well. Currently, it is doing nothing. So it only just accepts, but it is there just in case in the future I need to modify or extend it. So it will basically just set the status to healthy and carries on. All right, so this is an example how the service definition looks like. Here you can see that I can define the cache layer where I want to cache. You can define multiple caching tiers. Let's say you can cache to an SSD disk, you can cache to an HDD, or you can cache to RAM disk, depending on what kind of content you're distributing. You specify the domain name. This domain name will be automatically registered with CoreDNS as well, and will be resolvable globally. You set a name, you set an origin type. In this case, it's static, and you can set what your desired upstream origin is supposed to be. And so if you deploy this service, you get the aforementioned configuration of the cache nodes. All right, so the next step, this is the caching. This was the caching phase. I needed to solve how I'm going to resolve those domains. CoreDNS has a bunch of plugins, and probably I would have been able to come up with a reasonable configuration which would have worked, although I decided, since I already have CRDs and is extensible, I decided to build my own plugins for CoreDNS. So they do connect to the Kubernetes API, and they are pulling, they're watching the event stream of changes which are coming from the Kubernetes API server. So whenever you create a new service or a new zone, the configuration is automatically loaded in CoreDNS without any restart or reload. In terms of functionality, you can define some prefix routes. It's another CRD. You can define, if you have a specific list of prefixes which you know they do belong to this ISP where you have a caching node, you can specify those, and you can direct all the customers basically coming from the source IP to a specific node. Alternatively, which is most often the case, it can do GeoLookup based on MMDB lookup database. I have even upstreamed a few changes into CoreDNS because I needed bigger granularity, not just country-based, but based on regions. So that's already in upstream CoreDNS. And I'm also doing consistent hashing per region. So if you have multiple servers running in a single region, CoreDNS will do consistent hashing based on the domain name, just to make sure that you increase the cache hit and miss ratio. And it can do fallback routing. So there is another component which is doing health checks, and it is updating the CRD whenever a node is down in a specific region. If there are no healthy regions, but the CoreDNS is supposed to redirect the client there, it can fall back to different regions, just to make sure that the customer will always get a valid IP address, even though there are some downtimes in certain regions. Yeah, so these are the CRDs I mentioned, how they look like, which CoreDNS is working with. On the left side, you have a prefix list. You can define prefixes, and you can say which prefixes should be routed to which region, to which location. And on the right side, I have a definition of a location where you can specify attributes which are loaded from the GeoLookup table. And based on that, you will get certain weight, and you will be routed basically to a location whenever you get the highest weight available. And yeah, you can have multiple node groups in a single region. As I mentioned, you can have nodes with SSD caching, you can nodes with HDD caching, or whatever caching you define. This is all configurable, and on the service level, you can select which kind of service caching you want the content to be cached in. So, as I mentioned, everything is basically more or less live, and everything is reloaded automatically. This is achieved using the informers. Informer is a mechanism, is a wrapper around basically getting the available resources in the Kubernetes API server, and then instantly storing a watch sequence from the specific resource revision. So, and this turns basically those resources into an event stream. So you are not working with a simple get post request, but you are basically effectively working with an event stream. And whenever the Kubernetes API goes down and restarts, the informer is capable of reconnecting to it. So it's very, I would say, very reliable and very fast. So you can quickly react to changes whenever there are changes in the certain resources. All right, I think I more or less covered all of these. As I mentioned, it's based on Nginx. I'm planning to fork it because there are some features that I'm missing. Especially, I'm missing the slices module, for instance, in Nginx, where it can more effectively cache large files. And since LLMs and huge files are coming, I think that's something which will be handy. It can also support key modifiers, which you have to specify. So if you have a query param width equals 1024 and width equals 2048, and those two requests are returning a different asset, which they like to do, in this case, then you have to specify those key modifiers, and it will make sure that the clients will get the desired size of the image. I mentioned that you can use S3-based origins. If you want to distribute private content or you want to distribute your content privately, you can use URL signatures. So that means the whatever URL you're just accessing, you will get the follow free until you put a signature towards the end of the URL as a query parameter. This way, you can distribute, for instance, private videos on your OTT platform. And there is both enabled, or you can enable or disable it. Right now, it's only in the basic configuration. That's also something which probably I should invest a bit more time in. And there is a basic analytics and monitoring in place. So I have a specified log format, a version log format, and the logs are basically streamed to the central location, and it is using a automated aggregation and rollups. So every 5 minutes, I get a information a line in a timescale DB database where I can see like which service, in which region, how many megabytes were downloaded and uploaded. And based on that, I'm building I have built a few Grafana dashboards. I'm not sure if it's visible, but here you can see that the first service over there sent 800 megabytes in the last, I don't know what time frame was that, and it downloaded only 4.3 megabytes from the upstream. So the cache hit ratio here is 99%, which is an ideal scenario, let's say. And right now, recently, I've been working on a UI interface. I'm happy that I was able to get it into a point where the demo is right now fully functional. So if you want to give it a try, it's running at portal.demo.edgecdn-X.com. I would be more than happy if you try it out and give me some feedback. And yes, I think we have enough time. So just in case, I pre-recorded a few videos, but I definitely want to show it. How does it work in real life? So this is the UI. The deployment is running in Siebel Cloud. And you can click through a few projects, and within the projects, you have a few services. I created this service specifically for this event. So if you want to find out, this is a domain name which the CDN allocated to you. And so if you want to find out how the routing works, you can try DNS checker. And if you throw it in, you will see that the IP address will be resolved. And based on the location, you might get different IPs. So the requests coming from the US are ending up, let me make it a bit larger. So the requests coming from the US are ending up on a different IP address than the requests coming from Europe, for instance. Yeah, so that's about in a nutshell. I would like to also show you some insights. How does it work? So on the left, you can see the live logs coming from CoreDNS. And on the right side, I have prepared a small script that will guide us through all the use cases. So the first use case, so these are the two caching nodes which I have available. And I will be just resolving the domain name, which I've added as an argument. And you can see that this domain name was resolved to Frankfurt 1. Why? Because why? Because I'm based in, I think I already lost it somewhere. Why? Because I'm based in Europe. This is my IP address where the request was coming from. And I was allocated to the location to Frankfurt 1 because this is the closest cache node to my location. I mentioned to you that it is possible to set certain prefixes. I have a prefix installed here. It's a prefix from, I think, a Spanish orange random IP address, basically, which I just put into the routing table. If I use the very same request, although I specify my source IP using an eDNS extension, it's an extension for DNS where a resolver can inject the IP address of the original request where it was coming from, anonymated. Then you can give slightly buried information to your resolver, like where this request is coming originally from. And if I did that, even though this IP address is in Spain, but I configured the routing to send this prefix to New York, so I was forwarded to New York instead of Frankfurt. And in the next test, there is a health checker running, which is updating, which is health checking all the nodes throughout the region, throughout the CDN every 10 or 20 seconds. I'm not sure, but whenever a node goes down, I will get an update on the logs on the left side. This should appear in a couple of seconds. So I threw basically the caches in Frankfurt right now, and I see that I got an update. That means something happened. So if I hit enter now, I was redirected to New York City instead of Frankfurt. And if you look at the logs, you can see that I was supposed to redirect it to Frankfurt, although the node was not healthy, and there are no other healthy nodes in this region. So my routing engine redirected to New York City. And after a few seconds, the pods came back already, so there is an update already. If I do it again, I'm routed to Frankfurt now. So this was all live demo, not scripted. And just to show you why this control plane is so great, let me create a quick service. Hold on, I did first a example upstream. I'm going to use this one. Yes, if I create a new service, I'll set the upstream URL to this, the host header as well. I will set the caching tier to SSD. These are the query parameters, which are cache key modifiers, which I mentioned to you. We don't need any of those here. And I can select if URL signatures should be enabled or above should be enabled. I'm not going to enable that for this service. So whenever this is ready, the issuance is in progress. There is already a certificate being generated. And as I mentioned, the challenge, this is from the RCP dashboard. In such case, the challenge is copied over to each region. So I have two pending deployments right now. One of them is at New York, and the other one is at Frankfurt. So the challenge is copied to all the endpoints. And whenever, how is it called? Whenever Let's Encrypt verifies the correct tokens, the certificate will be issued and it will be all torn down. I guess it's going to take a couple of seconds, maybe minutes. But until then, you already have an allocated domain name from the CDN platform, and this domain name should be already configured in your DNS, since everything is automatic, and you can see that you're already getting an IP address, and this IP address is routing me to Frankfurt. Yeah, so the challenges are provisioned. So within a couple of seconds, I can imagine that the certificate will be ready. We can check the logs if we see any. Yes, there are already endpoints hitting it. So that means Let's Encrypt is already querying this token. And whenever they verify that the domain name belongs to you, they will issue you a certificate. And everything you should see live in the dashboard, but yes, it's taking a couple of seconds. So just to summarize, looks like was really bored, so I built a full CDN on top of Kubernetes. In terms of project state, it is more or less still a hobby project. It's not really productional everywhere. I do have a POC deployed at Liquid.io. They are a small Silicon Valley-based startup, and they are doing sort of a Heroku alternative. And the owner of that company reached out to me that he likes the idea, he'd love to try it out. The POC is deployed for a couple of months there, but no production customers yet. It's only a few demos so far. As I mentioned, the portal is open, the registration is open, so I would be really glad if any of you or all of you or someone just basically opens it, registers it, and give it a go and test it out if that works. And I would be more than happy if you give me any feedback on the project and what features you are missing, or what do you think. If any of you have any experience with other CDN vendors, if you can tell me like how different is this compared to this one or that one, or what are the features that you are missing. And yeah, as I mentioned, I'm looking for beta testers. I'm open to collaborations. So any one of you who's working for a, let's say, web hosting companies, or you work on IPTV platforms or OTT platforms, I think this is a nice product. So I'm more than happy to help. And yeah, hopefully one day I will be able to somehow bootstrap it. There are some CDN providers in Czech Republic. Why don't we have in Slovakia as well? So we will see. And of course, if you give it a try and let me know how that works, I promise that if one day if I manage to bootstrap, I will give you a lifetime access to the CDN for free. And you can find me on socials. I do run a YouTube channel where I'm sharing the updates with your project. The project is fully open source, so you can find me on GitHub. Feel free to follow me, and I do send updates on the mailing list on LinkedIn, and there is a Laudable-generated website available as well. And here's my email address. So if you want to reach out to me, feel free.